Hi everyone, welcome back to Math 245. We are jumping into a new topic, statistics. Starting from here on out through the rest of the term, really, we will be talking about statistics. And before we get into that too much, we really have to go over a few definitions because statistics is kind of a different beast when it comes to math, so we do require a lot of definitions. That's what this lesson 47 is all about. Our definitions are here in this box. The first one is a population. A population is a total collection of persons, things, or objects under study. Gathering information about an entire population often costs too much money or is virtually impossible. So, for example, right now the census is out, right, since it's 2020. It's really, really challenging and very expensive to get census data from every single person in the United States. Statisticians kind of have to go back through and fill in the blanks and estimate certain populations in certain areas because it is really hard to get everybody to respond to the census. So instead of trying to collect data from every single person, we collect something called a sample. This sample is just a part of the population, and this is usually easier to do to collect data from a sample. And if we do it right, it gives us a good idea of what is going on in the population. A sample should have the same characteristics as the population that it is representing. So this is pretty important. Our sample has to be representative of the data that we are wanting. For example, if I were to try to collect census data for everybody in Oregon, but I only sampled people from Linn and Benton counties, that would not be good enough. I couldn't get the estimates that I needed because it's not representative of everybody in Oregon. So our sample does have to be random, and it has to be representative of everybody that we are trying to get data from. Data are information about populations or samples. Data can be numbers. We call those quantitative data, like age, income, stuff like that. Or they can be words. We call those qualitative data, stuff like hair color, favorite food, stuff like that. Generally, there are unknown characteristics or variables about a population that we wish to know or that we want to study. A parameter is a number that is a property of the entire population, and a statistic is the number that represents the property of the sample. So the parameter and the statistic are really closely related, but the parameter is of the whole population, and a statistic is the sample. So we have to be careful to differentiate those two things. The statistic is an estimate of the population parameter. Since the statistic is only the property of the sample, it's not guaranteed to be totally accurate of the whole population. But if we pick our sample well enough, then it can be really close. So let's go through an example with all of these words in mind. So Billy wants to determine the average income for the 1,560 employees at his office. He decides to survey 100 random employees. From this scenario, we want to describe the following words. So what is the population? Well, remember, the population is the entire group of people or things or whatever that we are trying to determine something about. So in this case, the population is the 1,560 employees at his office. That is the whole population, but I don't think Billy has time to go through every single one of these, so he decides to survey 100 random employees. What is the variable that we are trying to get at here? Remember, the variable is the unknown characteristic about a population that we want to know. In this case, we want to know the average income of the employees. Okay, what is our sample? Well, Billy chooses to survey 100 random employees, so that is our sample, the smaller portion of the entire population. Oops, employees. What about the data that we are collecting? Data is the information about the populations or the samples. So we want the average income in dollars. And the data that we will get are the average income from each one of these employees. So the data is income from each of the 100 random employees. That is the data that we are getting. Our statistic is the number that represents the property of the sample. So our statistic here will be the average income from the 100 employees. Or maybe average income of the 100 employees. And then our parameter is the number or the property of the entire population. So the parameter here is the average income of all 1,560 employees. All right, so our population was everybody at the office. The variable that we were after was the average income of these 1,560 people. Our sample was 100 random employees. The data that we collected was the income from each one of these 100 random employees. The statistic is the average income of those 100 surveyed employees, and the parameter is the average income of all 1,560 employees. Now, the statistic and the parameter are hopefully really close to each other, but it is possible, as we'll see later, that if we pick somebody who has a really, really high or really, really low income, then the statistic and the parameter will be off a little bit. But it's our hope and our goal that they will be really similar to each other. All right, so this is a quick rundown of these definitions. We'll be using these words a lot in the lessons to come, so hopefully this gives you a little idea of how to use these words. Let's move on to lesson 48. I'll see you there.